In this video, we're going to look at how to find horizontal asymptotes for a given rational function. So if we have a rational function, we know that that's a quotient of two polynomial functions. So in the numerator, we have a polynomial function of nth degree, and in the denominator, we have a polynomial function of the mth degree. So there are three situations that can occur when we're trying to find horizontal asymptotes. So the first one says that if the degree of our numerator is greater than the degree of our denominator, right, if n is greater than m, then we will not have any horizontal asymptotes, but we might have potentially something called an oblique asymptote. And oblique asymptotes are something that we will discuss in a future video. If the degree of our numerator is less than the degree of the denominator, then there is a horizontal asymptote, and it's going to have the equation of y equals 0. So if n is less than m, then we know that there's a horizontal asymptote at y equals 0. In this case, we call our rational function proper. So if the numerator's degree is less than the denominator's degree, then the function is called proper. And then the last case is if the degree of the numerator and denominator are equal. So again, there is a horizontal asymptote, and the way that we find the horizontal asymptote is it's going to be the equation y equals a divided by b. It's the coefficient of our highest degree term in the numerator divided by the coefficient of the highest degree term in the denominator. So that's going to be the equation for our horizontal asymptote in that situation. So let's go ahead and try a couple examples of this. So in this first example, we want to find the horizontal asymptotes for this function if they exist. So we have to look at the degree of our denominator and the degree of our numerator. So in this case, we have a linear term, right? We know that the degree of the numerator is 1. So the degree here is 1. And we know that the degree of the denominator is 2. So here the degree is 2, which means that we have the case where n is less than m. The degree of our numerator is less than the degree of our denominator. So we say that our function f of x is proper, right? It's proper because the degree of the numerator is less than the degree of the denominator. And we know that when our function is proper, that we have a horizontal asymptote at y equals 0. So this function will have a horizontal asymptote at y equals 0, or the x-axis. So let's take a look at this example. So for this example, we're given the function f of x equals 8x squared minus x plus 2 divided by 4x squared minus 1. So again, we are trying to find the horizontal asymptotes if they exist. So again, we have to consider the degree. So the degree of the numerator is 2, and the degree of the denominator is 2. So degree is equal to 2 for both of these, which means that n is equal to m, which is that third case that we talked about. So that means that there is a horizontal asymptote, and it has the equation of y equals a divided by b, where a and b are just the coefficients of the highest degree term for our numerator and denominator. So the horizontal asymptote is going to be at y equals 8 divided by 4, which is 2. So we have a horizontal asymptote at y equals 2. So again, quick refresher. To find horizontal asymptotes, there are three situations, right? If n is greater than m, there's no horizontal asymptote. If the degree of our numerator is less than m, then there's a horizontal asymptote at y equals 0. And if their degrees are equal, then we take the coefficient of the highest degree term from the numerator and denominator and take their quotient, and that's where our horizontal asymptote will be.